example of solving a polynomial equation if you're given a partial list of the solution set for the equation. So here it says find the solutions of the polynomial equation x to the fourth minus 3x cubed minus 7x squared plus 15x plus 18 is equal to 0, given that 3 is a solution of multiplicity 2. So they're telling us that 3 is a solution to that equation twice. Now if 3 is a solution, then x minus 3 is a factor. So I'll be able to use that idea in order to factor out the factors that they tell us already exist and solve the equation the rest of the way. So the first thing I look at is that it is in descending order and there are no exponents missing on the countdown of the descending order. So after fourth power, I can expect a third power, and I have it. After third power, a squared term, which I have. After a squared term, the first power, which I have, and then the constant. If any of the powers are missing when you've written it in descending order, you need to use a 0 coefficient for a placeholder for that missing term. Now, what we're going to do is use synthetic division to help us out with this process. Since I know that 3 is a solution of multiplicity 2, I'm going to use synthetic division with the number 3 and the coefficients of each term of the polynomial. So coefficient of 1, negative 3, negative 7, 15, and 18. And then skip down a line and draw a horizontal bar. Now to do the synthetic division, you bring the first number straight down without doing anything to it. And then you multiply the number that is the root, the number in the half box, times the number below, so 3 times 1 is 3, and write it up underneath the next number. And then you add. Negative 3 plus 3 is 0. And then you repeat the process. 3 times 0 is 0. And then add negative 7 plus 0 is negative 7. Then 3 times negative 7 is negative 21. And then we add 15 plus negative 21 is negative 6. And then we multiply. 3 times negative 6 is negative 18. And then we add negative 18 plus 18 is 0. So getting a 0 as a remainder tells us that this division goes in evenly. So x minus my 3 is a factor. And the bottom row of the synthetic division table gives us the coefficients of the descending order terms of the other factor. Now this started out as an x to the fourth, and I divided out an x to the first. So my first term here is going to be an x to the third. So I have 1x to the third. I have no x squareds. I have minus 7x and minus 6, and then that is my factorization then equal to 0. So I partially factored the original equation. Now they told me that that 3 is a solution of multiplicity 2. So I have another root of 3 that I can use as factoring out the x minus 3. And I do it in what's called the depressed equation. So using the coefficients of the polynomial in this other factor, because that's where the rest of the roots of the original equation are hiding. So I'm going to use 3 again. And I'm going to use the coefficients of this remaining factor, which we can recall we got from this bottom row. So I'm going to have a 1 for the coefficient, a 0 because the x squared is missing, and then my negative 7 and my negative 6. Remember, come down and skip a line and draw your horizontal bar. Bring the first number down without doing anything to it. Then 3 times 1 is 3. Put it up underneath the next number. 0 plus 3 is 3. And then 3 times 3 is 9. Negative 7 plus 9 is 2. And then 3 times 2 is 6. And negative 6 plus 6 is 0. So again, we've got our 0 remainder. We had the x minus 3 that was already factored out. and x minus 3 of the next factor we just got, and then the remaining portion of the factored form has coefficients from this bottom row. And remember, we started with a fourth degree. We factored out an x to the first, which took it down to x to the third. And then we factored out another x to the first, so now this is x squared. So 1x squared plus 3x plus 2. And now the remaining factor that our roots are still hiding in is quadratic. So we can solve this quadratic final factor either by factoring or by completing the square or the quadratic formula, any of those aspects. X squared plus 3x plus 2 does factor. It factors as the factors of 2 that add to get 3 are x plus 2, x plus 1. So then our solutions to our polynomial equation, take each factor and set them equal to 0. And then solve each of them for x. So add 3 to both sides, there's x equals 3. Add 3 to both sides, x equals 3. Subtract 2 from both sides, x equals negative 2. And subtract 1 from both sides, x equals negative 1. So you see that we have 1, 2, 3, 4 solutions. My 3 was a solution multiplicity 2, like they said in the setup of the question. And looking at this, that's the full list that we have, and so that are the solutions of our original polynomial equation.